Sir, you are not audible.
सौरभ सौरभ आपका आवाज नहीं आ रहा है। सौरभ आपका आवाज नहीं आ रहा है। प्लीज चेक।
Sir, you are not audible.
Saurabh, please check that you are not audible.
Am I audible now?
हाँ, अब आया आपका आवाज, इसलिए आप शुरू से नहीं आपका आवाज आ रहा था। You may start from the beginning.
I have to connect from my mobile. So what I think you haven't heard what exactly what I was saying. So basically in the last two sessions we have discussed about the different climate models and their practical applications. And Dr. Dimri sir have discussed broadly about the GCMs, RCMs and the downscaling of climate data also in the last two sessions. So we are taking the glimpse of last two sessions, as well as we will discuss the global open data source available for the climate parameters. And there may be there are things that may be repetitive for some ones who are experts and who are experienced of climate modeling, but I think this thing will be helpful for the UG and PG students as well as the beginners of the climate modeling field. So basically we discuss the agenda first. In this agenda, basically we are going to discuss about the brief about the climate models, brief about GCM, RCMs, representative concentration pathways, climate modeling group, and open source data available. That is for precipitation, meteorological variables, climate models, RCM availability over South Asia, global flood, rainfall and stream data, discharge data, stream flow data, hydrological data, and we also discuss about the different hydrological models that are available open source, and like the USGS hydrological models, SWAT models, and NASA open softwares. Okay, so let's move ahead, and so we'll discuss about the climate model first. Like this training is basically primarily aims to expose the PG students and researchers about the climate models, right? And we know that the model is basically a physical representation of system, mathematical representation of a physical system, right? So climate model is basically the mathematical representation of a climate system. What is climate system? It's the atmospheric, ocean, cryosphere, and land surface processes that are happening in the climate. So we include all these parameters, these four parameters: atmosphere, ocean, cryosphere, and land surface. Okay. So in this climate system, there are physical processes that are happening, and there are different parameters involved, like precipitation, temperature, relative humidity, wind speed, and others. Okay, so we're going to discuss about these parameters also, and the principle behind this climate model is basically the physics principles, the conservation of energy, mass, and momentum. So these models use a number of data points to transfer energy and mass and momentum from one grid to another grid. And why these models are required, that is also because we are doing the climate modeling, we are discussing about the climate modeling, why it is useful. So basically the meteorologists use the models for the prediction of climate, right? So we cannot collect the future data, right? So model is required to use the estimate. We can predict the different scenarios for the future weathers. So climate models are basically the mathematical equations that use scientists to predict the future climate. Now, it may be wondering, right, that the climate agencies, how the climate agency is getting data for the climate models. So, as per the sources from the WMO, World Meteorological Organizations, weather information is collected from more than 15 satellites. And there are 100 buoys, stationary buoys are there, 600 drifting buoys are there, 3,000 aircrafts, 7,300 ships, and more than 10,000 land-based stations and AWS. AWS is the automatic weather station. So these stations basically they are collecting the data, and that are basically that weather services are automatic surface observing systems. And this data basically is a primary source, you can say, for the climate models. Okay, so now we going to discuss, like we have discussed about the models, and we are going to discuss about steps involved in the construction of model. So there are 3 steps basically: building of 3D maps of Earth climatic system, where Earth has been divided into the grids, and there all the physical, chemical, geological, biological climate process are represented by mathematical equations. Similarly, the second point is like when the equation has been developed and then we have established the physical laws on that grids. So we basically develop the computer codes to for those equations that we have established. Okay, so that is a huge computer code. And then finally that the we are going for the making the model run through time. So we have to include the time step, because time is an element in the climate model. Like we have to get the data for hours, days, months, years. Okay, so shorter time steps requires the more computation. Now we discuss GCM models. GCM model is a general circulation model. That is, you can say, it's the most advanced model. Most advanced model that global climatic system for simulating, predicting the greenhouse gas scenarios. Okay, so it is very complex. You can say like the complexity can be explained in such a way, like if you check the computer code of these models, they can fill the approximately 10,000 to 20,000 pages of computer code. So can be imagined like how complex systems they are. Similarly, the very high resolutions, high horizontal resolution there in the GCM model, I think that's around 250 to 600 kilometers area. Basically, they are covering for the climate predictions. And also, GCM models also because they cover the different multiple regions, right? They are not a region. They are you can say that it's a they are the broader aspect of climate. They will cover in a you can simulate the atmosphere. They can simulate the ocean. Ice is land for the whole planet also. And they also include the time step that we already discussed. So they can predict the data values in hours, minutes, and time. And output of these models basically they primarily derive the climate science and help the scientists that how the human activities are affecting the Earth climate. Okay, so this is about the GCM models. Now come to the RCM models. RCM is basically the regional climate model. It's basically the numerical climate prediction model that has been, you can say it's a downscaled version of GCM. And Also, it can be created with the help of observed data sets that simulates the atmospheric and land surface processes. And RCMs having the high resolution data and of land surfaces, surface characterizations, and the Earth system. As we know, like that RCM is a downscaled version of GCL, so it is a limited domain. So the value of these models are constant with the boundary conditions. Okay, so they provide the coarser resolution because as compared to GCM, and they are just you can say that RCM solutions are not consistent when we compare the global model, because we have downscaled the RCMs. So and they are constant with the boundary conditions. Now there is one point that we have to discuss, like in representative concentration pathways, RCP. Okay, we have discussed this in the previous sessions also, but I'm just going to elaborate it, like what exactly the RCP is. So RCP is a greenhouse concentration, not emission. So that is the trajectory basically adopted by IPCC. So they have suggested the 4 pathways that were used for climate modeling and the research for the IPCC 5th assessment. So what they have considered the 2 scenarios: RCP 2.6, 4.5, RCP 6, and RCP 8.5. Okay, so these are basically the possible range of radiative force, and we can say the radiative force values in the year of 2100. So RCP 2.6 means 2.6 watt per meter square value in year 2001. RCP 4.5 is 4.5 watt per meter square in the year 2000. What is the radiative force? Radiative force is like it's the energy which is absorbed in the earth. What is energy that has been reflected back to space? The difference between of these two is the radiative force. So just going to discuss about the RCPs. Like RCP is RCP 2.6, we can say it's very stringent. So they are taking emission, like they are considering it like carbon dioxide emission has been started declining by 2020. You can see in this figure also. You can see in this figure that RCP 2.5 is getting decline after 2020, and they have targeted that the carbon emission will go to 0 by 2100. So by RCP 2.6 scenario, basically they are assuming like the global temperature will not rise more than 2 degrees centigrade by 2100. When we consider the RCP 4.5, that is the intermediate scenario. Okay. In this scenario, the emission was considered as a peak around . Hello? Hello? Am I audible? Can you please confirm? Yes. So in RCP 4.5, we are discussing.
Sir, there is a problem of echo.
Just a minute. Is it fine now? Hello?
Yes, sir. Now
Now
it's
it
fine.
is okay?
Yes, sir. It's okay, sir.
Hello?
It's okay, sir.
Hello.
Now it's okay, sir.
Hello.
Yes, sir.
Hello.
You are
Can you
audible
please
now.
confirm that echo is not coming now?
Sir, there is no echo problem right now.
Okay.
Hello.
So we are discussing about the RCP 4.5, right? Which is gradually declined. We are saying that this scenario considered like after 2040, the carbon emission get declines. Okay, and the temperature that likely to be increased by 2 degree or 3 degree by 2100. So this means that the mean sea level five of IPCC. Okay, so all the climatic models have been considered these scenarios for predicting the climate, and now then IPCC has also recommended in the new scenarios also that they have considered the shared socio-economic pathway in CMIP 6 basically. So they are saying like now RCP 1.9. So they have shared the SSP. SSP is a shared social pathway. In these scenarios, basically they have accounted the socio-economic aspect also. So now comes to the CMIP. CMIP is a couple model intercomparison project. In climatology, you have heard about that many times, like CMIP 3, CMIP 5, CMIP 6. So basically, it's a couple model integration project, which is a collaboration of framework designed to improve the knowledge of climate change for global circulation models. That is GCL, right? So that project is basically under the World Climate Research Project, and working group on basically coupled modeling. There are a number of climatic modeling groups has been involved in CMIP modeling. Okay, and so we have already discussed the CMIP 5 scenarios. That are the RCP scenarios we already discussed. That has been included in the climate models of CMIP 5. Okay, so CMIP 6, that is the new version of scenarios that has IPCC has been included. In this, the socio-economic aspect have been considered for the predicting of future climate considerations. So I'm going to discuss about now various climate modeling groups. So climate modeling groups, there are a number of climate modeling groups. I have not included all, but there are some few famous, and you can say like it's a big climate modeling group that I have listed down. That's the National Center for Atmospheric Research. Geographical Fluid Dynamic Laboratory, GFDL, Goddard Institute of Space Studies, National Center for Environmental Modeling, Goddard Modeling for Assimilation Office, and Center for Multi-Scale Modeling and Prediction, CMAP. Okay, so this is about the climate modeling group. There are maybe number of groups that I have not included all the groups. So in this, I have just taken a reference. There is a study was conducted in 2008 for considering the several emission scenarios that we have already discussed, right? In 2008, they have started this study, and they have taken the scenario that carbon emission will be decline from the year 2010 in a sustained rate of 3%. Okay, so on this study, they have found like the temperature would be rise around 2 degrees centigrade by 2100. And they have also predicted if there is no measure has been taken and the global emission has been continuously rising, that temperature will be rise around 7 degrees centigrade. That was possible, true, right? But it was not likely, but it was possible. So now come to the our main discussion points, the open source data sets. So there are many freely available data that is available globally around the world. The different climate sites, different climate modeling groups, they are providing these data. So meteorological data is there, hydrological data, climate models, hydrological models UI based, hydrological models based on Python programming, thematic data, and Python or script or source code data that is basically available freely for the study purpose. We are going to discuss now. So let's discuss about the precipitation first. So in this precipitation, there are a number of data providers. First comes the Aphrodite rainfall data sets, which is available on a graded basis on daily frequency of 25 kilometers square scale. Okay, and this data is available for 1951 to 2050. This is very useful information. Many of you don't know about this, so please, even researchers, PG's researchers also, this information very useful for you, that where you can find the data for your climatic studies. Okay, so Aphrodite is providing the data from 1951 to 2015, and I have also shared the link where you can find this data. Okay, so the second one is the TRMM and GPM satellites. So this is the graded measures and satellite gauge data that is available in 25 kilometers square scale. This is also a daily data, and it's present from 1998 say to 2021. So presently also you can get the data for 2021. Similarly, terrestrial hydrological research group, the Princeton University data set is also available for precipitation. They are also providing the graded data, and the observational precipitation, which is including satellites plus gauging data. Okay, so this is also a 25 kilometer scale data that is available in 1948 to 2013. I have also mentioned the link where you can get this data. CRU data set is also available, that is providing the data for monthly basis for 50 kilometer scale, and data is available from 1901 to 2016. Next is the CMORPH, that is CPC morphing technique data sets. So this is also a global agency which is providing the data for measured precipitations, satellite microwaves, and sub-daily or daily basis, and in 25 kilometer scales, and data is available in 2002 to 2017. And that's AG-MERA NASA Agriculture Model Intercomparison and Improvement Project. That is basically providing the data for daily basis from year 1980 to 2010. So actually I have mentioned all the source link also. So we will share this sheet. So it will be very helpful for you all to get the data sets and source information where you can look for these data. Okay, so the next data set is GC map, near real-time product. That is the graded data, which is 3 hourly, 1 hourly for 10-kilometer scale. So this is near real-time data they are getting provided, and this data is also available for present also. GSCN Global Historical Climatological Network Station data sets. That is NOAA, National Oceanic and Atmospheric Administration. They are providing the information from 1901 to up to present, and the data is available daily. This data set is also CAAST means climatic hazard group infrared precipitations with station data. This data is available from 1982 presently. And GPCP, that is also providing the daily data, 3 hourly data, and 1 kilometer scale. So it is providing the data in the duration of 1996 to 2015. Similarly, ECMWF, that's the European Center Medium Range Weather Forecast. They are providing data from 83 to 2018, but it's a coarser scales. It's 80 kilometers per grid they have taken, and this is the daily data. CPC Global Participation Precipitation Data Sets, that is provided by NOAA, and that was basically a graded data from available from 1979 to 2018. So now we have already discussed about Aphrodite, but I'm just going to show you how you can get the data for Aphrodites. Okay, so this is the link where you can look for the Aphrodite data. Once you hit this link, this web page will appear, and where you can find the data. You have to register. You have to do a registration first, and then you can get the raw data as well as the other data also. Like in the screen, you can see, like, you can choose the version, you can choose the grid type, and you can choose the year. But the data is only available from up to 2015. Maybe it's giving an option for up to 2021, but data is available for 2015 only. Now come to the other meteorological aspects, like other data, which is like temperature, minimum maximum temperature. So GHCN station data sets, that is provided by NOAA, and they are providing data from 1951 to 2018 on daily basis. Okay, and the relevant link is given beside to this. And WorldClim version 2, that is providing data from 1970 to 2000. And they are providing data for temperature, solar radiation, and wind speed. And that was very higher resolution grid, 1 kilometers per grid. They are providing data from 1970 to 2000. And ECMWF, European Center for Medium Range Weather Forecast. So they are providing data for minimum temperature, maximum temperature, solar radiations, and data is available in an 80 kilometer scale of 1983 to 2018. CRU data set, they are also providing the minimum temperature, maximum temperature, PET, wet day frequency, cloud covers. And this data is available from 1901 to 2016 years. And data is available in the grid of 50 kilometers squares. And Giovanni, NASA is also, they are providing the all atmospheric variables that we have discussed. And the data is available on a grid basis from 1901 to 2016. Berkeley Earth, that is the basically providing the temperature data daily or monthly on grid basis. I have mentioned the reference site. Now move on to the climate models. So climate models, the NASA Earth Exchange Global Daily Downscale projections are there. So these are the bias corrected data that is available for 21 models for RCP 4.5 and 8.5. RCP we already discussed, right? So that is available for precipitation and minimum maximum temperature. And the grid resolution is 0.25 into 0.25 grid is there. Similarly, Government of Canada is providing the data for 3 models, that is the CAN, ESM2, Lucid, and Geomid, and they are providing the data for all the 4 scenarios of RCP, and that is available from 2006 to 2100. Yeah. Similarly, CMCC is also providing the data for different models and for all the 4 scenarios. CNRM data nodes is providing the data for CFAX and CMM5, considering all the 4 scenarios of RCPs. All data is available in 2006 to 2100 years that we are going to discuss. Now, GFDL New Jersey is also providing some data for RCPs. ISPL France data portal is also providing the data for climate models, and nor SG data node. So these models or these basically portals are also providing the climate data of different RCPs that we have discussed. Now these are the CMIP5 GCM models and other models where we can get the data. So I have mentioned the list for GCF models where you can get the link. Hello? Hello, my screen is visible?
Yes, sir.
Okay. So I have mentioned the link for this CMIP5 GCM other model download. So they are providing for the data for all the RCPs mostly, and the data is available from 2006 to 2100 years. Okay, so total GCM CMIP GCMs are 14 in under this links, and they have considered the 39 RCP scenarios under different models. I think the power is already gone off here again. So I'm just have to shift, I think. Sorry for the interruption. I think that the power failure is again happened, and I think I have moved out from the WebEx. confirm that I am audible. Hello? Okay, is visible? Yes. Okay. So let's go ahead. Sorry, my apologies. There are power interruption happening in my place. So that's why the presentation is getting disturbed. So we are discussing about the I think we are discussing about the CMI models. So we have already discussed this. Now comes to the RCMs under CMIP 5. So these are the RCMs basically that has been available in the South Asia. So these RCMs are available with the Codex data basically, Codex South Asia data. So the nodal agency for the Codex is the Indian Institute of Tropical Meteorology of India, that is in place in Pune. So you can get the different models, different climate models. I have already mentioned that having RCMs are there. So this data is available on almost 50 kilometers scale for the 2006 to 2100 for all the RCP scenarios that we have discussed, right? For RCP 4.5 and 8.5 scenario. Similarly, the SMHI and RC4 six ensembles members. So they are also available for the Roseville Central Region atmospheric model version 4, and that is available for 50 kilometer areas. And the next one is the MPI CSC that are also providing the data for RCM data. And I have also mentioned the link that you can download the data from the provided links. Okay. Now I have also just added a screenshot for Codex data download. So we have to, if you need any data from the Codex, any precipitation data for your region, you just have to log into the Codex website that I have given, and also the CCCR TP server, that is the Center for Climate Change Research, Indian Institute of Tropical Meteorology, Pune. So this data is specifically available for the climate change studies.
Hello.
So
Sir,
here
there is a problem with your voice.
Sorry?
Sir, your voice is doubling 2 times.
Okay. Is it clear now?
Yeah, now please, yes.
Okay. So, in this Codex data, when you going to this link, provided link, you can see like you have to select the institute of IIT. Okay. And whether you want a historical data is available from 7. That is, you can see from 1901 to 47. There are scenarios of RTC 415 and RTC. So we have to select the number, we have to select the time frequency, which data what are the variables, like here are the precipitation, sense max for temperature maximum and sense temperature minimum. So there are a number of variables. If you go to the site, you can see there are number of variables are available, and you can just select this data, and you will get the required data for your need. Okay. So now comes to the hydrologic data. Hydrologic data is hydrological data that is data is available in Boli, satellite data set. That is globally available now 500 meters, available from 2000 to present, and there are the length of the map available is 40 in the given size. They can never water level data. So the data to a limited radar data so that is available from the daily up to present. So next is the global surface water data. So there you need a part and have mentioned the slide here. The data is available in 1984. There is a high resolution matrix of global statistics in Downscaling. Similarly, the global runoff data center GIC that is providing data for the multiple time scale. Especially the discharge data. They include the India discharge also. Now comes to the satellite river discharge. There are a number of monitoring sites available. So that is the flood observatory Colorado that are providing the data for satellite river discharge. So you can see in India also there are a number of sites. They provide the river discharge service monitored by the satellite. Similarly, the global flood rainfall stream flow and live data that is available by DFMS, that is global flood that is provided under the University of Maryland. So I have mentioned the slide here. You can see like you can visualize the flood. There are floods that are around the world. To this live. Now, consider steam flow data. Steam flow data is also from the Center of Sustainability and Global Environment. That is the National Institute University of Wisconsin. So, they are providing the average discharge value over the area for globally. You can see here like India, station of Kaya. So they are doing the value for the average discharge value over the particular. Now comes to the Track India data set. There is track CAAST-JNKVV site that is providing the India data set for hydrology of track. So they are providing the dam, they are providing the graded weather of IMD graded weather. They are providing the landing, soil mass, soil evaluation. So this data set can be accessed from the now comes to the free various data that you can go to freeGIS.rt.com and you can get the number of free various data sets that is available for global. Now for India you have to go to the global site that is the government platform under the flow. So you can get the remote sensing images, you can get the number of products that are available in global site for the CLA. Now comes to the India virus. India virus is the single video solution for the we can see a comprehensive of aquatic data, assistant data that is available for the video. So they have maintained almost number of data, surface water data, groundwater data, many data is available for this. So you can go to India website and you can just see there, and you can search, you can access, you can visualize, you can understand different types of climatic maps are available there. So water data is available in India. Now come to the socio-economic data. Socio-economic data for world that is provided by CAAST. CAAST is basically a socio-economic data and application center that comes under NASA. So they are providing the global information for socio-economic. Now comes to the Earth Explorer manual. Earth Explorer. This is used for the downloading the remote sensing. And there are multiple satellite products that are available in free. You have to register for this Earth Explorer and you can get the data as per your need. Now comes to the last satellite battery. That is also the remote sensing satellite provider. And you can get the potential satellite images from under your your automatic data processing download it to the so we can explore this line viewer that basically process automatic process data doing automatic data processing. And you can download the different satellites from visual class. Now comes to the glacier environment. But glacier data set we maintain all the glaciers around the world, or all the continents, they are maintaining. So Rudolph glacier inventory 2.0, I have given the link for the page. So you can just explore like what are the data we have number of data. Now comes to the remote download data set. So there are 5 major sites. There are multiple sites. There are 5 major ones I have listed. So global is a global visualization here. NASA Earth observation, ESA scientific data, NOAA classes, and now. So these 5 service providers are there for remote sensing data. They are providing the list. Now open source GIS software are also listed down. So we have number see the name solid GIS, graph, hydro, GIS, open them, GIS, Saga, GIS. So these are the open source that are available free. And one more explore this software. So it can be used for data. There is a evaluation also done like graph, GIS, business map, and so almost all have some familiar device for all the various software. You can process the vaccine and last and some editing also can be done. They can be work in the window and build platform, and they are also a support. They can support the community support is available for the software. Now comes to the open source advanced now. So that is the data one. That is look for the advanced modeling software that is the physical deterministic model, and it can able to build the system of processing. Similarly, the big model is also a advanced modeling. We are focusing the data for before. Ice model, index model is a butterfly model that is developed by the Stanford University. So these are open source. And usually American micro scale model, simulation volume model, and GSO model. These models are also GSO for groundwater source stability model. So these models you can go to and have mentioned all the they are openly available, they are freely available. Now, my advanced modeling pattern-based software are also there. These are very open source. So, what to provide, we are doing the pattern and basically not so it's basically used for the groundwater model. So, they use the pattern to groundwater. Similarly, the hydro conductor rate model are also very good. They basically use for the hydrological model. LSMC model is a lump hydrological model. That is available. There are many other models also. I am not listed down, but the estimate I think. Now we've already built the V3 model, and now comes to the high-tech 50 model package and hydro is also there. So these models are already given the link for the model. So what exactly we are looking at Python model for so usually hydrological models are also available. Like when we already looked at that predicting the one of the global climate change here is that for visualizing the climate change happening worldwide. Hydrothermal model is also given a specific program with a multi-phase converter code. So what means I think the model is similar to the macro model. So you can these are all the models which I am discussing with the open source model. So you can go through this model. I will also mention the link where you can find it. Now, not to end up with separate water model system is also here. Full cost and now the NASA open source software have given some examples. Like one of models for the model. Loss previously assessment rules are there. Land surface temperature knowledge visualization. So there are modules such as converter when download the climate data different formats. So there are converter tools available and we have OBS right PBS converter light correction classification. So these are the first software that are available in the market. Now comes to the Python library. Python library is number of you go to the about hydrology.com or this.com or because mention the hydrology, you will find that there are different types of Python software library for hydrology. So you can go to this and now comes to the real this system data expression. This is also a Python software. You can code instruction file, copy a raster file in a different format. And where you can build a map, you can draw compute on them, and there are a number of tools available to visualize the building the kit from the setup. That's why you have to so there are a number of options that are available in detail, and then links I have mentioned here. So we suggest like you just go and explore this thing and look at all the software and they are affected in this. So this information is very useful, freely available. So one of this code now I think I have covered almost all the public publications and if you any queries you can ask. Are you going to share this presentation? So this will be helpful for you later on. I think there is no questions as of now. I'm using this session. Thank you very much to all the participants. You are all available session. Thank you. Thank you all. Thank you very much.